Hi there. Hi, everybody. Thank you for joining today's session. I hope you are waiting for a great weekend ahead. Um, I'm just waiting for a few more people to join in, but I believe we can start right now. Uh, so, today's topic is primarily based on the agentic framework. Okay. And then again, agentic framework is kind of, you can say it's a vast jargon, you can say, but we will be morely focusing on the MCP and A2A prospect and how we work on multi-agent workflows for how can we actually work for the multi-agent workflows in the future. So for the agenda, there's going to be a brief introduction of myself and what I do. Then we'll start with the agentic Gen AI prospect. We'll discuss A2A MCP. We'll be going into a brief demo as well for the multi-agent framework, and then there's going to be a live Q&A. Okay, so today we are going to discuss orchestration on multi-agents workflows, a critical piece in building truly scalable and productive ready Gen AI system. And we'll explore how technologies like MCP and A2A are reshaping the way we build intelligent agent systems. You'll also learn how to overcome the challenges, improve system observability, and enable seamless collaboration between agents in complex AI pipelines. Uh, we're jo- so let's start it from there. So about myself, my name is Abdullah Mahmood. I am working as a practice lead in Royal Cyber. Uh, Also, what is Royal Cyber? So with over 20 years plus experience and 2,000 plus employees globally, we have the capacity and capability of 500 plus certified consultants, and we have 10 physical office globally in 5 continents, and we have more than actually 600 plus clients across the globe as well. So let's start. So first, what is it? It's essentially an autonomous system made of AI agents of different sorts using foundation models and working in concert to provide the results. That's agentic AI. Why is it better than the previous tools instead of those rule-based tools and more strict systems? Because it can handle more complex workflows. It can generate better results, reduce human intervention, and enhance productivity as well. But it does bring a lot of challenges, and some of those we'll discuss today. You'll know first is replacing the bunch of human processes. Okay, so there's always going to be resistance for the change. There are a lot of potentials for getting things wrong, like hallucination, error, biases. You know, these are certain parameters that are we do not have much control on them. But then again, those agents can run freely and run loose. And now that we are taking about federate agents architecture, where some of those agents are essentially someone else's or developed by someone else, how do you really control those things? So it brings a lot of risk around security and governance and how you can trust those systems that start generating things by themselves. So we need to have a proper governance on all of those different things. Okay, so we have three generations as we see them. First analogy is like chat GPT generation. We ask questions, we get an answer out of most of them. Okay, it is actually integrated with the LLM information, and then we start adding all sort of agents and RAG tools. And so that interface and external systems and have copilots or tools to interface with those other systems. So now we have a lot more knowledge bases. We can create actions, not just sort of answer question and answers. Those recent generations with identical AI and multi-agents and reasoning. Now we can build very complex workflows and start building systems that can replace humans in certain tasks and can be more sophisticated. They can avoid hallucinations and errors as well. Just to give you an example of an application for a use case, these are three generations. The first one, you are trying to ask questions. doesn't interface, doesn't interact. It's an external survey, doesn't have the capability of answering the questions and may even hallucinate and think it as an answer. Then the generation is called RAG. Now, what is going to do for a second part? It can answer questions, it can generate queries, it can give you a probable, effective, and effective suggestions as well. You could see you're getting sometimes a lot more closer to human interaction, a lot more productivity, and then again, these are the ways that it's going to scale initially. Okay, now, okay, is my screen sharing? Yeah, okay, okay. Just give me 1 second. I believe uh, there is a problem. Okay, yeah. So everything good has also sometimes bad or challenges, and those challenges will be overcoming as the technology matures. So let's compare two scenarios. One is having a manual process with human handling all those different flaws and AIs and those agents to communicate with each other. So the manual processes are always kind of resource augmented, and it takes time, it takes efforts to get those things done. But to mitigate those things, there's going to be there's going to be a progressive increase in the agentic part. Okay, they're slow, they're again agenting and much faster. On the other hand, where we are looking for a caveat, human, who can actually work on those things at times faster, but slower as well. Okay, now I believe my screen is sometimes okay. So let's talk about agentic AI. How does it actually work? So how does it actually work? Essentially, we need some things that orchestrates the processes to make the decisions and have a sort of control on the flows. And we have tools to interact and external systems, whether it's a RAG or it's an API or external services, or the ability to browse the web and gathering information. Okay, and to process all of the data, whether it's visual data, it's audio data, it's textual data, we need to sort a feedback loop to learn and improve. These are the main components of energetic system. What are the essentials? What are the essentially the new things that we need beyond what are already in the traditional AI or using element? Hmm. We need to have a planning. We need explicit goal management. We need to know whether the agent or the system produce the right results and are giving the right quality as well. We need those real time perspectives and contextual awareness tools to understand again the entire process. We need to have a memory in the system. One agent responds, the other one needs to take the response and pass it to the another one. We need to augment the different results to a broader response to get a broader response as well. Okay, so all of those things require integration with short-term memory. We need an orchestration of all of those different tools, and the topologies are becoming more and more complicated. Usually, we had like that, it's a tree structure. You have a branch, you go left or you go right. With those systems, it's more of an orchestration, more of a collaboration of independent tools that talk with each other. It's more harder to orchestrate those things. We need those specialized frameworks that need to talk to some of them internally. And it requires a tighter monitoring, it requires a control, it requires a governance, because those agents can sometimes run loose. Now, so These are the things that you need to consider when you're working on an agentic AI. The underlying you have is the infrastructure and those different data resources for an entire lifecycle management of the application. Some of them operations like log monitoring, metadata, configurations. Some of them are the data used for actual application like vector data, different tables, key value stores, graph database, and so on. And some are operational for context of the application. For example, history of these sessions, the question and answers. So there is a data layer on top of, you can say, bunch of services or series of orchestration. In any case like Kubernetes or monitoring tools or observability, we have those LLMs that may be in the cluster or some external services like OpenAI or GenAI. And then we have a workflow is comprised of multiple steps that take a specific that steps into a specific generic role. Okay, and of course there has to be a certain type of guardrail, but some of them are the application, the agentic workflow. And these tools is sometimes uh, take an example of interface on external systems. Now, one of those things that we need to see, that we are actually looking and seeing that is emerging, well, is sorted of the notion of the composition. So we have the workflow, which is very uh, application specific, or maybe able to even build workflows that are flexible through to be used in multiple applications. But we have resources that want to access whether these are LLMs or these are agents or these are tools or data sources. And we do not necessarily want it to have all of those things in the same cluster. Maybe we even want some of these to build and develop and manage those. Maybe a cloud provider or someone else is building and gives us a source code in the Git repository, or even a README. So the general idea of those standards like MCP and A2A is the ability to decompose the architecture, which provides scalability, observability, better vision, and control on so on. Nice thing about those tools is that we build it while we build it, it provides full automation of anything from code to production at scale. All the monitoring is built in. There is a specific resource allocation including GPU management, and it incorporates the external services like Google services that we'll see. So you can choose what you want to build by yourself and deploy, and what you want to leverage like external services. And there are large and emerging assets and component libraries that you can use and go on and deploy. Okay, so let's take a few moments here to dive into the very exciting topic of multi-agent orchestration. No one Now one of the things to share is here that we think about agents and multi-agents. As you know, described, one of the things is I observed is that to have these things in a context of evolution, it's evolving daily. I mean, like it has been rapidly progressing, and this evolution that you see here is a mimic of a lot of that thing. We of course start with an LLM and prompt. Then you actually use a rack or to retrieve models called function calling, or along with, and then it comes along with the element to figure out how and what, which API to call and what argument and how to execute them. And soon enough we're just reflecting the start to add the reasoning loop to determine if we understand the user's intent. We review a plan, we figure out how to which tools we should use, and based on all of those dimensions give better and quick response. And now we essentially have agents speaking to each other because they all have the capability of rack tool reasoning, and then actually interfacing within their own system until this point is in which you can have them talk to each other. This is now the stage in which we are fully start to realize the full automation of the workflow. So, if I was to summarize it, essentially, we are not just going to see what we started to, we are just like to see the enterprise landscape evolve into a multi vendor and multi agent. Long gone are the days that just a single agent that might perform a single task or perform just a chatbot experience or go seek a piece of information. So, now the question for us is how we can support this evolution. And if we think about it through the lens of actual, it's going to be a very simple scenario. Let's think of one where it's a world of multi vendors and multi agents. You're trying to create a simple travel agent experience that allows you to think from how you can actually go book a flight, and once you have searched the inventory, how do you actually go to the best hotel, how do you actually go and design certain activities, how do you actually get a guide that may be able to help you during the trip. This sort of notion is simply a representing a simple but realistic representation of everything that we have talked about regarding a multi-agent. Agents that can communicate with each other, and agents that may be able to guide each other. If you the peel this underneath this, you'll start to realize that some of some very specific requirements that you need in order to be able to get those agents to communicate with each other. So, first and the foremost, those agents cannot just go look out for each other. There must be a way to discover, hey, I'm an agent. This is how I do it. And this is how you actually can communicate with me, and then a specific task can be performed. Okay? It's kind of a collaboration. Client and agent must support an interface enabling agents' requests, giving them a clarity and information that they're asking for. Now, rather, they are much more sophisticated. They have they need to have a context. They have to be able to they actually need to understand the prompt that we are giving them, and it requires them to interface and interact with different systems in order to give you an answer. And hence we see the birth of what we call nowadays agent to agent protocol. The need to interface with within and collaborate with to a simple thing, maybe given a summary of a document or to help me commit something into another place. This practically opens a protocol handling the dynamic and multimodal nature. So that one of the key prerequisite of this type of protocol you have is to understand within the protocol how you actually allow it and think around things like authentication and governance. So and to in order to activate a particular agent within the framework, you have to out about build a standardized prospect like HTTP and JSON. As you can see on my screen right now, it's a basic interface of an A2A protocol. So we have an end user, we have our laptop, and we are requesting a supervisor agent that is connected to a mesh of multiple agents, and it's working on multi-modality framework architecture, and it's giving us the responses in terms of what we are asking. Now, so that's A2A, but how does it relate to MCP? Well, MCP is even more interesting because a lot of these agents, as I described earlier, they are really only as good as the data that they can interface with. And when you get into a particular notion of data, you quickly realize that MCP is designed for all tools and data sources that an agent needs to interface with. Whereas A2A only allows you to actually create a collaboration between agents themselves. So if you look at the dynamics in negotiation, that happens from agent to agent. It helps those agents discover which agent and which agent card they need to communicate. They understand the capabilities, and they understand whether these notions that I want to do or perform are particularly modally within each other. Whereas MCP allows you to start thinking about what is the data source and consistently retrieves the information so that we can ensure that there is a quality maintained. They are reputable in the source of those. And of course, MCP interacts with these things such as agent development kit that allows you to facilitate access to a number of data sources. You can go into an AWS data source, you can go into databases, you can also go into GCP Drive, Google Drive, and so on. Those two capabilities combined are the foundation parameter from which we can actually build a multi-agent system. And as you can see over here, this is a representation of how A2A can work within an MCP collaboration. Okay, so now we have the necessary building blocks. The next natural question is, how do we actually allow folks to participate in a democratize agents notions of agents? So let's talk about that. It starts by understanding who are the users and who are those agents. These are the business users who may want to be able to automate certain processes that don't want to be involved or by any coding. They want a simple no code based scenario. And as you can see, simple building an agent and running it in a simple registering it for other to use, it's a certain governance framework around it. For those, we use agent space as a framework to discover an agent that are in place to be able to invoke those agents, customize them, and as you need using those agent builder, all with no code, and then publish them for the rest of the team to use it. You may be a business This may be a business owner process, or you might be using it as for a SAP based scenario. You may be even somebody that may be handling, in the case of travel agent, a part of a process that allows somebody to know which sort of backend system to go into, or simply put an agent that might allow you to understand which system to connect into. Then there are folks who may want to take an exciting existing agent and actually add a little bit more customization to it. So I would like the agent to actually go into two data sources and reason between them before they give me an answer. For that, we have ADK. It's called Agent Development Kit as well. You can start to build it. You can start off thinking around the sources. It integrates with using a source of MCP, etc. You can think around allowing it to either seek human intervention or automatically go and execute a task. All of these characteristics uh, can you can define inside of an ADK, agent development kit, and deploy it into a governance model. In this instance, you can either do it in the cloud run, the classic way, or you can use the agent engine, which takes care of the important things that you can uh, describe within your organization, like monitoring, logging, ensuring the state of consistency for all the agents. So all of the operational elements are built into an agent engine, and you don't need to worry about it. Okay. Okay, and that finally, to your own point earlier, to my own point, maybe you don't want to build everything yourself. You can actually, like if there isn't any best practice available, you can use a pre-built agent from the partner who developed those and publish them. It's basically called a SaaS, fashion-based gallery, where you can actually have those agents. You can view them, look at their functionality, and then move ahead. The second thing is, how do you actually make sure that these agents, this is an agent space in an open ecosystem. Now, of course, the underlying parameter of agent to agent and MCP are the underpinning of that, but the framework itself should be agnostic by not only allowing, for example, one provider in the case, in my case, you can say, can connect to any particular agent, like, I mean, like, not an agent. As I said earlier, I want to have a lang graph, or want you to be able to use some other type of capability like Crudia. We see all of these things at time in the agents and the gallery as well. So the platform itself is quite open. Similarly, we should actually start thinking about it when we think through the parser around, can I go and use some of those agent capabilities built out of the box, or not everybody needs to build and search engine. That sort of core capabilities that you can build and everything allows me to actually access those facilities natively. I can go and use those agents that are built out of the platform, and can a third party agent be provided. Now, can I customize them? And this is where the bottom two green boxes that you can see in here become important. So as I start to think about customizing those agents, I want to start thinking about the answers I'm getting. Can I connect those into a better grounding? Can I create a learning loop and a cycle that allows me to understand what my agent has behaved or responded dynamically? These things are not disconnected. Agents are talking to systems, and they leverage models and allow this to happen in a dynamic way. So I believe we can actually move to a demo. So just give me 1 second. Let me share a sort of demo that we created. So this is a type of a travel agent, you can say. It's a mesh of agents, and I'm going to talk to this agent and ask him to give me a walkthrough of the complete prospect of how it's working. And it's basically, it has a master agent, then it has an agent that is going to inspire me, then assist me into planning and then booking and trip. So let me say hello. How can I help you plan this? Okay, okay. So I'm going to ask it to inspire me about uh, America. Okay. So it's going to give me an inspirational idea about what I'm looking into. Okay. So the response is New York City, San Francisco, and Yellowstone Nature Park. Okay. Yes. So I'm going to choose New York. So it has triggered, it's neither it says only triggered and master agent. It has already also triggered an agent that has the vocabulary of areas and places. Okay, so New York has a lot to offer. Could you visit Central Park, experience stuff like that? Yes, let me say about Central Park. Mhm. Visit. So now it has provoked an agent that actually is going to actually try to plan dates and areas for me. So let me say, okay, uh, how about I visit it on 25th of August. Okay, I would like to say for 5 or maybe 3 days. Okay, I can say I am departing for from. Hmm, what should I suggest? Kiryu. So as you can see, it's interacting with me. It's eventually as long as I proceed further, it's going to ask me about the flights as like yeah. So as you can see over here, it's providing me the details of the airlines and their fares as well, and it's providing me an iteration of the stopovers and the time where I can go and move back and forth. So this is a, an exciting era that we are living in. We are providing, we are actually blessed to have the agents work for us and showcase us what we are proceeding with and how they're representing us and how will they eventually reduce the human intervention and automate those things. So I hope that you guys like this, and and I believe we can move for the Q&A session. So yeah, let me close my screen, and we can start from here. Okay. Okay. So um, okay. So I have a question. How do I handle security vulnerabilities with MCP? So MCP agent exchange structured artifact, which creates an attack surface we mitigate with. So we can use each agent can use sandboxing environment to isolate a container and resource quota. We can have strict JSON schema validating of every handoff. We can have signed request and response between agents with JWT tokens and mutual TLS. And we can have circuit breakers to stop runways, loops, or spam agents. Okay. And how do I best monitor these agents for your experience? What are the best open source tools that can be used to monitor agents? Um, so Prometheus and Grafana can be used. Their metrics cover CPU, memory, and API latencies. And OpenTelemetry is also one of those tools that can be leveraged. Okay. And what were the design and coding standards needed to feed into a system? So basically, modular agents design like single responsibility principles, strong type enforcement or agents inputs and outputs, error handling plus retry policy baked in an authentication layer. And for the LLM standards, RAG first, policies, knowledge base, compliance, and rules that store externally. Fine tuning only for the domain specific tones and terminologies, not logical. And how do you think about minimizing latency and resources? Okay. You can use event driven orchestrations like async messaging, and each agent receives, you can use also context compression so that each agent received minimal prompts, context via embedding and retrieval, not full history. This will actually help in a faster recurring method, but obviously you can prone it to give you more information. I believe I believe these are the questions that I have received so far. I would like to thank everybody who has joined. Please feel free to reach out to us in case any additional information is required, and obviously we'll be happy to assist and we'll be happy to respond to any particular queries that you guys have, and even give you a best notion of, you can say, thank you guys, thank you so much.